In this video for Positive Maths, we're looking at the Junior Cert Higher Level 2014 sample paper. This is question 10 from paper 1. A plot consists of a rectangular garden measuring 8 meters by 10 meters, surrounded by a path of constant width. The total area of the plot is 143 meters squared. 3 students, Kevin, Elaine and Tony, have been given the problem of trying to find the width of the path. Each of them is using a different method, but all of them are using x to represent the width of the path. Kevin divides the path into 8 pieces. He writes down the area of each piece in terms of x. He then forms an equation by setting the area of the path plus the area of the garden equal to the total area of the plot. Part 1. Write in terms of x the area of each section into Kevin's diagram below. So we'll take it bit by bit. Because they tell us at the start that it has a constant width, that means that this side is also x, so therefore the area of each square is going to be x squared. So if we look at the rectangle at the top, we have x and 8, so therefore the area is 8x. Same with the one at the bottom. And the rectangles at the side are going to be 10x and 10x. So we also need to write the area down of the rectangle in the middle. So 8 by 10 is going to give us 80 meters squared. Part 2. Write down and simplify the equation which you think Kevin got. Give your answer in the form ax squared plus bx plus c equals 0. So we're told he forms an equation by setting the area of the path plus the area of the garden equal to the total area of the plot. So even if we form our equation in words first, area of the path plus area of the plot equals the total area. So let's start off at the top left hand corner. We have x squared, moving to the right, 8x plus x squared plus 10x plus x squared plus 8x plus x squared plus 10x. So we'll count them to make sure we've got them all. 1, 2, 3, 4, 5, 6, 7, 8. So that's the sections around the outside. And then we also have the section in the middle. So that's 80 meters. So that's the area of the path plus the area of the plot. We're told this is equal to 143 meters squared. So we just need to simplify this so that it's in the form ax squared plus bx plus c. So first of all, we're going to find the sum of all of the x squared terms. That's going to give us 4x squared. Now the x terms, we have 8x plus 10x plus 8x plus 10x. This gives us 36x plus 80 equals 143. So our next line, we have plus 80 minus 143. So we have 4x squared plus 36x minus 63 equals 0. Elaine writes down the length and the width of the plot in terms of x. She multiplies these and sets the answer equal to the total area of the plot. So part 3 asks us to write in terms of x the length and the width of the plot on Elaine's diagram. So if we start off with the width at the top, we have x plus 8 plus x. So that's going to give us 2x plus 8. And then the length, we have x plus 10 plus x. So this will give us 2x plus 10. Part 4, write down and simplify the equation which you think Elaine got. Give your answer in the form ax squared plus bx plus c equals 0. So in order to get an equation, she multiplies the length and the width. she sets the answer equal to the total area of the plot. So again, our length multiplied by our width is going to be equal to the total area. So we have 2x plus 8 multiplied by 2x plus 10, and that's equal to 143. So we're getting that from the previous part of the question. So now we just need to simplify it again so that it's in the correct form. So 2x by 2x gives us 4x squared. 2x by 10 gives us 20x. 8 by 2x gives us 16x. And 8 by 10 gives us 80. So again, we just need to simplify. So we have 4x squared plus 36x minus 63 equals 0. Part 5. Solve the equation to find the width of the path. Part 5. Solve an equation to find the width of the path. So if we're looking for the width of the path, really what we want to do is find x. So we have 4x squared plus 36x minus 63. So the first thing I do is I draw my brackets. And here we're just solving the quadratic. So I have to consider the factors of 63 and the factors of 4x squared. So for 4x squared, we have two options. We have 4x multiplied by 1x, or we have 2x multiplied by 2x. For the factors of 63, we have 63 multiplied by 1, 21 multiplied by 3, and 7 multiplied by 9. So we're going to try the factors 2x and 2x first. And let's try 7 and 9. So because it's going to give us plus 36x, the bigger number will probably have the plus sign. So now we need to check. 9 by 2x gives us 18x. 2x by minus 7 is going to give us minus 14x. So this is how we check and make sure we get the value that's in the middle. So 18x minus 14x is going to give us 4x. So 4x does not equal 36x. So therefore we cannot use these values in our brackets. So let's try again. This time we're going to use 2x and 2x again, but we're going to try it with different factors of 63. So let's try 21 by 3. So 2x plus 21, 2x minus 3. 21 multiplied by 2x gives me 42x. 2 multiplied by minus 3 gives me minus 6x. So 42x minus 6x is going to give me 36x. So that's how we check that we've used the correct factors. So now we let 2x plus 21 be equal to 0, 2x minus 3 be equal to 0, and we solve for x. So we have 2x is equal to minus 21, x is equal to minus 21 over 2, 2x is equal to 3, so x is equal to 3 over 2. So both of these are meters. So we go back and check, have we answered the question? We have found two values for x, but have we answered the question? They want us to solve an equation to find the width of the path. So what we need to realize really is that if we end up with a minus value, so we have minus 21 over 2, we can't find the measure if it's a negative value. So therefore we're choosing x is equal to 3 over 2. So x 3 over 2 meters, or we could say 1.5 meters. If you have trouble solving the quadratic equation just using the brackets, remember you can always use minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's the formula in order to find x. You still find your two values, and again you have to pick the positive value in this case because we're talking about the length of something. So to recap, what we want to notice is that Elaine and Kevin both found the same equation. 4x squared plus 36x minus 63 is equal to 0. So we could have used really either of these, but really the fact that they're the same means we're solving it for Elaine's equation and for Kevin's equation. Part 6. Tony does not answer the problem by solving an equation. Instead, he does it by trying out different values for x. Show some calculations that Tony might have used to solve the problem. So first of all, what Tony might have done first is let x be equal to 1 and then calculate the area of the full plot. So what we want to remember is that we're told at the start that the total area is 143 meters. So this is really the answer that he's looking for. So if he let x be equal to 1, then the width is going to be 1 plus 8 plus 1. So that's 10 meters. And the length would be 1 plus 10 plus 1, which is 12 meters. So then, we might have found width multiplied by the length is 10 multiplied by 12, which is 120 meters squared. So that's 23 meters less than what we're looking for. So then what he might have done is done the same thing again, but now let x be equal to 2. So again, his width is going to be 2 plus 8 plus 2, which is 12 meters. The length, 2 plus 10 plus 2, which is 14 meters. Width multiplied by the length, 12 multiplied by 14, which is 168 meters squared. So using x is equal to 1, really he needed an extra 23 meters in order to get the correct answer. And using x is equal to 2, he needed 25 less meters. So what he might have realized is that if x equals 1 is too small and x equals 2 is too big, he may have then tried x is equal to 1.5. So let's try that. So the width, 1.5 plus 8 plus 1.5 is going to give us 11 meters. Length, 1.5 plus 10 plus 1.5 is going to give us 13 meters. So our length multiplied by our width, 11 multiplied by 13, and we find 143 meters squared. So this really shows that he could have found it not using an equation if he tried some of these values, but he may not have tried 1.5, so it might not be the best way of doing it. But also by doing this calculation, it confirms that our answer for part 5 is correct. Really for part 6, they're not looking for us again to show that x is equal to 1.5. They want us to just show some of the calculations that Tony might have used. Part 7. Which of the 3 methods do you think is best? Give a reason for your answer. For this type of question, there is no wrong or right answer. Really, what's important is the reason that you give to explain your answer. I would suggest that Elaine's method was the best. The reason then, we can say that her method was the most straightforward. And she used, just continue the answer up here, she used the formula for area of a rectangle in her method. We could also add in a line, maybe suggesting that therefore she's less likely to make a mistake. You don't really need to, write that much or anything, but again, just to be able to give a reason for your answer. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter.